Really?
Yeah. Karen gives feet rubs.
So
All right.
we need to redraw that.
I'm going to do something else with it. So, let's say that this time, Avogadro goes further, and he does it at STP. What have we learned STP is? 273 K and 1 atmosphere. Okay? Now, if he knows the temperature and the pressure, and he knows the number of molecules, you guys said a minute ago that they're going to have the same volumes. Now, Avogadro figured out the volume. He found the volume was going to be 22.4 liters. Now, yeah, this has a name. And I point this out to you because it's found on the front page of your reference table. At the bottom of that top chart, it's on 145. The fifth line has a name. It's called standard molar volume. I don't do a whole lot with this, and I'm going to teach you how to calculate it. I used to teach people how to solve problems with this number, but I've quit doing it over the years.
Wow.
I just have lack of time. I used to teach people how to solve multiple ways, but just lack of time. But this is called standard molar volume. Okay? So, this number of molecules is equal to how many moles?
That number.
How many moles are in that number?
1.
Yes. 1 mole is equal to 22.4 liters. Now, you can only use this number is equal to 1 mole if you're at STP. Now, I don't teach people to solve using this because there's a formula that I think is easier to use. And that's where I'm going to go today. Some teachers really like using this number and like using a T-chart to solve. It's not the method I'm going to teach you, okay? But should you see that term on the state test, standard molar volume can be found on your blue reference table. So don't freak out. Just use your blue reference table and look it up, okay? Now, you can still find this number using the formula I'm going to teach you today. Now, you might have to use Avogadro's number, though, to solve a problem, which is why I did talk about it. So, what are we going to do with Avogadro should you have to use it? Does everybody have what they need?
Yes.
Okay. I'll give you a minute to write that down. Here's a typical Avogadro problem.
sorry, was it? No, it wasn't. That's stupid. They had a planet out there. Yeah. That's so stupid.
Are we ready?
No.
Are y'all done with
No.
y'all got a game today? Y'all coming to our soccer team?
Oh, Charlie, you told me to come to it. I really don't feel it.
Dang, Tomas.
Wait, no, you just say no again.
Are you guys gonna win? I'll go for you guys to win.
We all played West.
Are you guys gonna win?
So if you guys.
Maybe, they've been falling off. We beat Redford at the beginning of the season.
I know.
And they lost to Redford the other day, 3-1.
I didn't get a new brace.
That's your shirt.
Huh?
You are
Yeah,
that's
that's
all.
His brace matches his shirt.
No, that's all.
Oh, it's headphones.
Thank you.
You're cool. Thanks.
All right, so I'm gonna adjust our later we're supposed to be back today.
Where'd you go?
I don't know.
No, we stay where.
You told me it wasn't gonna be a Thursday and Friday, but I thought it would be back today. All right, so if we look at the question, what's different about this one than the ones you worked on the quiz? In case you see something like this on the test, what looks different about it?
Size molecules.
First thing is it says molecules. That's the first thing you should notice. What else do you notice? Okay, it's got molecules in it. That's important. All right, it's got molecules. All right, it says same temperature and pressure. Okay, that's a key. So if it says same, do you know what the temperature and pressure is?
No.
You don't. You can't assume 273. Samara, put your phone up. You cannot assume 273 or 1 ATM. So if it says same, that tells you that there's no formula that you can choose when it says same. Because you don't know a temperature and you don't know a pressure. Okay? It's not one you can pick. So, can you use a T-chart? Okay? What would you want one for? What are they asking you to find? They're asking you to go from molecules to molecules, right? All right? Do we have a T-chart that allows us to go from a molecule to a molecule?
Yes.
Well, we do, but have we ever done that before?
No.
No. Okay? So, the first thing that should jump into your head is, I'm going from a molecule to a molecule. All right? Are volumes the same? If the volumes are the same, what do we know about the molecules? They're going to be the same. So check your volumes. Are the volumes the same? Yes. The volumes are 5 liters here. The volumes are 5 liters here. If the volumes are the same, the molecules are the same. So since the answer is yes, then the molecules have to be equal. So the molecules here were 5.23 times 10 to the 25th. So the molecules have to be 5.23 times 10 to the 25th. That's your answer. Do you have to actually do any calculating here?
No.
No. Okay? You don't. If the volumes are the same, the molecules are what? The same. There's nothing to calculate. Now, what if I try to be sneaky on the test? What if I tell you that this volume is 5 and I change this volume to 10? What did I do to the volumes? What would you think you would do to the molecules if I did that? So how do you actually double something? You multiply it by 2. Okay? That is as hard as the question would get, is multiplying it by 2. Any questions about how to do that? Okay. That's it. That's all there is to Avogadro. All right. This is the new law we're going to learn today. The ideal gas law. If I had to take a shot in the dark and guess which one you would see on the exam, my guess is you would either see the combined gas law or the ideal gas law. If I had to pick, I'd go with this one, but it's strictly a guess. The ideal gas law is one of the most popular gas laws for beginning chemistry classes. Now, the reason is because it uses grams and moles. P stands for pressure. V stands for volume. T stands for temperature. Now, N and R are the new variables, but I have to go back and add some qualifications to pressure and volume. N stands for moles. Lots of people ask that very question. Why? Well, M stands for what? Mass. Well, since M is already used for mass, we can't use M for moles. So what's the next closest variable in the alphabet for moles? N, which is why most scientists probably picked out. Okay? Well, we don't use O for that one. No. All right. R stands for the ideal gas constant. Now, there are, I think, 3 listed on your reference table. I have chosen to use one of the 3. We could pick arbitrarily any of them, but instead of rotating between 3, it's usually easiest to use one and stick to the one. I have chosen to use 0.0821. The units that go with that are liters times atmospheres over moles times Kelvin. Now, the catch to using that one is those are the units that your formula has to be in to use that ideal gas constant. So every time you use that gas constant, your pressure has to be in this unit. What unit is your pressure in? Who? Atmospheres. So that means every time we use this formula, pressure has to be in atmospheres. So on your quiz today, you had 2 pressures. The pressures had to do what? You had to convert them so the pressures did what? They had to be the same. They had to match. In this formula, you only have how many pressures? 1, but it doesn't matter if they're the same. They have to be in what unit in this formula? ATM. Okay? The volume has to be in what unit? Liters. It doesn't matter if it's the same as the other volume unit because there's only one. This one, the volume has to be in what unit? Has to be in liters. Temperature has to be in what unit? Kelvins. Okay? Now, that's the only thing that is the same. Temperature still got to be in kelvins. That's the only thing that didn't change. N has to be in moles. That's new for us. And the ideal gas constant is a new variable. Okay? But volume and pressure have to be in these units. Okay? It's not about matching anymore. Is everybody okay?
Yeah.
Okay. Now, this is an easiest question as you're going to find. We're going to do 3 of them. I don't care what you write down. They're your notes. That would be a third period answer that I just gave, but they ask me that kind of thing all the time, I know. Sounds a little snotty to say that, but these are y'all's notes. You write down whatever you think you need. If you don't need all three of them, don't write all three of them. But when you go back to study or work the samples, if you need something to refer to, this is really all y'all have. All right, we caught up? All right, so tell me what about this question looks markedly different from what you did on the quiz today?
Moles.
All right, first it says moles. What else? What'd you say, Andy?
No, I'm just reading.
Okay. Aside from moles, there should be something else that jumps out at you.
Chemical reaction.
Let's see.
Because remember, at the end of the week, all the questions from today's quiz and all the questions from today, tomorrow, and Wednesday are all going to be mixed up. And y'all are going to have to sort and separate and figure out how to solve. And some of you are going to struggle with that. So how do you tell that this question is different from what you worked on quiz today, except from the moles?
Like
One measurement of what? Nope. Thought you were going to tell me it.
Volume?
Gas sample. Volume.
Ideal gas. Pressure, volume, temperature.
What about volume, temperature, and pressure?
It's not on there.
Oh, yeah.
I don't know.
There's only what?
One given to you.
There's only one given to you of what?
Each.
Of each what?
Temperature.
Yes, okay? On all of the questions you worked on the quiz today, there was at least 2 of everything, okay? You had a V1 and a V2. You had a P1 and a P2 on everything you worked. It said volume of something, what is the other volume? You had a temperature of something, what's the other temperature? But in this one, it just says, what is the volume? Is there another volume anywhere up there?
No.
No. It says STP. Is there another temperature and pressure anywhere up there? So could you use the combined gas law? No. Even though you've got a volume, temperature, and pressure given, there's no way to plug into the combined gas law, is there?
No.
No. That's what I want you to notice about this question. All right? So the easiest way to solve, because you're going to learn 2 more formulas tomorrow, because this says moles, is to use PV equals nRT. Now, after I show you 2 more formulas tomorrow, the vast majority of you are going to gravitate to this formula.
Oh, yeah.
Most of you are going to like this one.
Yeah.
Okay? Now, how are you going to decide which one to use on this one? When it gives you moles, which formula has moles in it? This one has moles in it. So this is the one to pick because it gave you moles. Okay? Now, the one that you're going to like better, or a lot of you are going to like better, there's nothing wrong with it, but can you plug moles into it? No. So you'd have to change your moles to grams, and then it'll work for you. Okay? Now, do we have pressure given to us?
Yes.
I hope so.
Yeah.
What's pressure? 1 atmosphere. What's volume?
We don't know.
We don't know. What's temperature?
273.
And what's R?
0.82.
All right. Now, Sophie yelled out R. Did anybody not know what R was? All right. R is the ideal gas constant. Okay? That number is right there. If you forget it, where can you find it? On your blue sheet. Hopefully, after we do this the rest of the week, most of you are going to know it. Now, before you can do the plug and chug part that I referred to, check your units. Is everything in the right unit?
Yeah.
Yes. That one's in atmospheres. That one's in moles. That one's in K. This is why I said a minute ago, this is as easy as it gets. Everything's in the right unit. So P is 1. We don't know V. 0.0680, 0.0821, and 273. All we have to do is punch it in. .52 is what I got. Okay. Now, what unit goes on it? I said the units had to match in all the other word problems. We have no matching units here. So how are we going to know what the unit is?
Liters.
How'd you know it was liters, Tomas?
Said it had to be in liters.
I said it had to be in liters. If we go back, the ideal gas constant has to be in what unit? That's how we know it's liters. Everybody okay with that?
Wait.
What's wrong?
How do you get it?
So 0.0680 times 0.0821 times 273, and then I divide by 1 on the other side. 0.0680 times 0.0821 times 273. Okay. Because we're dividing by 1 on the other side. Which won't affect anything.
Question.
Yeah.
Significant digits.
As long as you don't give me everything on that calculator, I won't take off for them. Okay? All right. Here's a slightly different one. Okay? This one will not be as easy because you will have to convert some things in this one. But again, same concept. You want me to let you try it before I do it?
Yes.
Okay.
Does this have to do with the diatomic oil and the gas?
Anytime we do something with diatomics, you have to consider, yes.
How do you do that?
All right, everybody had a chance to try it?
Yeah.
Almost. I just couldn't read it.
All right, I'll just write some stuff on the board while you're still working then. All right. All right, so did everybody come up with those numbers for where they should be placed based on what they got in the question?
Yes.
Everybody okay with where I got the volume placed? Was 150 milliliters, so I put it next to V. And the 15.2 grams would go for moles. And then R is 0.0821, and then 25 is temperature. Now, this problem doesn't have everything in the right units. So 25 plus 273 is 298 K. So I had to change this to kelvins. So 298 K. And then the grams, can I leave grams next to moles? Nope, so I got to change it. So grams to moles. Moles get to 1. Is nitrogen diatomic?
Yeah.
Yes. So nitrogen has an N2 for a formula. So it has a mass of 14 times 2, which is 28. So 15.2 divided by 28 is 0.542, because, you know, I still do significant digits even though I'm not holding y'all for it. All right, 150 divided by 1,000 is 0.15 liters. All right, so now that's everything converted. Is everything okay? Is everybody okay on the converting? Yes, no? Yes? All right, so now the plug and chug portion of the program. PV equals nRT. All right, so pressure we don't know. Volume is 0.15. N is 0.542. R is 0.0821. And temperature was 298. So to solve, I'm going to divide by 0.15. Divide there by 0.15. So pressure is 0.542 times 0.0821 times 298 divided by 0.15 at 88.4. 88.4, and then ATMs for our unit, because that's the unit for pressure. Everybody okay with that and how I did it?
Yes.
All right, everybody okay? All right, let's try one more. All right, y'all see how far you can get, and let's see how we're doing. Okay? Okay, now we're solving for mass. Everyone hurts the boys back up. Yeah. All the way down. She got moved. I did 2 girls, that's true, I'm positive. You're right beside the boys' bathroom. Yes. Absolutely positive. Yes. Yes. Yeah. Okay. Miller's room. I got you. Hey, hold on. I'm like, no, they probably don't know. You need to go have Miller.
Had her.
And y'all won't know the room number.
Oh.
It's okay, it doesn't matter.
It's right there.
Andy.
Never mind.
It's like.
Shush. You want the room number, not.
Yeah. The freshman place.
I got all that.
Maybe like,
I could tell it was beside the boys' bathroom.
maybe like 41, 42. The 40s are moving.
I don't know, the numbers
Because
are jacked
Miss
up.
Williams is 48. I'll tell you, and then Margaret is 44.
I got you.
And 42.
And Mo.
37. 37.
She said she had them out. All I know is she's
No.
beside the boys' bathroom.
No, it's 41. He's right, it's 41. Cause that visitor's parking right there.
Yes.
Yeah, it's 41.
Oh, God.
He's right there.
Like that. I was like 88.
Me too, me. I can't eat on the first time. We're not supposed to, but I eat it.
Yeah.
Well,
Yeah.
we had left trash one day. And then Gracious, she spilled her tea. She did.
All right. Are we all okay with where I put those numbers?
Yes.
Yeah.
So everybody's okay with where those numbers went? Okay. Are we okay with making the conversions? Okay. Keep working.
Yeah, first you still have your and she and that.
She was over there, still can't on the ground, looked at it, picked up the cup, threw it away and walked out.
Why is she in there?
She been there for about 2 months.
Oh, you can make that mixed up.
Are we okay with the numbers I converted?
Yeah.
Anybody not okay with any of the conversions I made?
Nah, I'm fine.
So you're okay with that? All right. Are we okay with the plugging and the chugging? That's the part that we're not okay with?
No, we're great at that.
Tiffany, what about you? I thought I heard a no on that side of the room. Was that you or somebody else over there? It wasn't you? Somebody over there moaned. So 3.52 times 0.3 equals n 0.0821 and 300. Okay. So what am I dividing by to get n?
You're dividing by 0.0821.
Hold up, wait. Your pressure, your conversion, why is it 3.52?
Because I divided by 101.325.
Yeah, I did that, and I got 352.1.
What, you multiply?
No, I did it by division.
356.8, 101.325, 1 ATM.
Yeah. 101.
0.325. That's times 10 to the fifth.
That's for PA.
It's for PA. All right, so n's gonna equal 3.52 times 0.3 divide 0.0821 divide 300. I get 0.042.
Point what?
0.0428 moles. All right, everybody there?
I didn't get that.
What'd you do? Do you have that? That math.
Yes, but I have the 3.5, underneath the 28.
Then you did your algebra wrong.
Wait, I was just playing with you.
No, it's aisle 5.
Andy, sit down and be quiet.
Oh,
Sit down and be quiet. All right, what's left? We're not done. What the question asks us for? It asks for mass. We're not at mass yet. This is where most people stop. Moles is not mass. You don't get full credit yet. Okay? You're not there. Moles and mass. Grams is mass. Every time I say mass, I'm talking grams. Okay? So draw a T-chart. 0.0428 moles. Moles on the bottom. Grams on the top. What goes beside moles?
1.
Now we got to go to grams. What compound did I give you up there?
Chlorine.
Is chlorine diatomic?
Yes.
So the mass of 35.4 times 1 is 70.8. So 0.0428 times 70.8, I get 3.03 grams. Now we have our answer. Questions about how I did that? No? All right, let's talk homework. Let's.
Let us,
If I had just, I would go home. I can't, this one person. What time is it? I got time to go. I love going to third period. I just literally hate being in red circles. Our classes is it's not even in my bag. I get hate numbers.
We're doing
0 through 0.
1 through 7. 1 through 7. B only.
the problems are, yeah, they
Yes,
look.
genius. They will say problems.
Hey,
1 through 7, B only. And 12 through 15, C only.
oh my.
Okay?
Dang you,
At
Squall,
least
I
she's
know
not
you.
making us do all of them.
That's a way to look at it.
I got
All right. 1 through 7.
And 15 through what?
1 through 7, B only.
12 through 15.
12 through 15, C only.
Brother.
He only.
All right, if you have a calculator.